Hey guys, welcome back. Today I'm going to start kind of a little bit of a series that's called Take a Look into My Lesson. And my last video that I'll link below if you didn't see was talking about the 4 components for a high quality, deep conceptual math lesson. And that kind of just went really quickly over the 4 parts that go into making a math lesson that helps your kids really think conceptually and deeply. And so today, I'm actually going to walk you through a math lesson and how I would plan it out, what the components look like for a 3rd grade math lesson. So I will have other grades and other concepts coming up, but this is where I'm starting because I teach 3rd grade currently. So if you are a 3rd grade math teacher, you'll get a lot out of this. If you teach other grades, but you teach math, you will also definitely get some things out of this because it will be applicable to your content, or you'll have students ready for this, some of these concepts, things like that. So I'm going to walk you through today a look inside a multiplication lesson or a multiplicative thinking lesson that I would plan and prep and do with my students. So let's get started. If you remember, the first component that I always start with is a review. So I'm going to show you a little bit what a review might look like. And this one I just kind of put together. I use Nearpod with my kids, so it would be in a quiz on Nearpod, but I wanted to show you what it might look like if it was on paper. It doesn't have to be fancy, it doesn't have to be anything. It can even be questions from your book. And if you don't think the questions are very deep, you can flip them and switch them and do things to them to make them deeper. So the first one I put, write 3 numbers that round to 400. So instead of giving them a bunch of numbers to round, flip that around and make them think of numbers that round to something. And I didn't put that it has to round like that's the nearest 100. It could be that's the nearest 10, that's the nearest whatever. I can think of it. But write 3 numbers that round to 400. And then this is why we have discussion, because I want to know what numbers my kids put, if they agree or disagree, and then they prove it to me by explaining it. The second one is some mental math kind of adding and subtracting practice, because we're starting a multiplicative unit. We probably came out of our addition and subtraction unit. We're from 2nd grade. They were doing a lot of addition and subtraction, so I want them to still be sharp with those skills. So it's just kind of starting with a number, adding some, subtracting some, and things like that in their head. Number 3 is draw a shape with a perimeter of 24 inches. Again, instead of giving them a shape and having them give me the perimeter or a bunch of shapes, I'm having them create a shape that has 24-inch perimeter, and then everybody might have a different one, and they have to go and prove that they each have one that has a 24-inch perimeter. And number 4, I only have 10 blocks, and how many do I need to make 230? The number 230. And in this case, I mean 10, like base 10 blocks. So on mine, I would have like a little picture of the base 10 blocks. So I only have blocks that are 10. How many 10s would I need to make 230, basically? So I can't use big 100 waffles, as some people call them. I can only use the 10s. What would I need to get out? So that's review, just 4 questions, simple, but they're a little bit deeper, and that's concepts we've already talked about, but keeping them in, spiraling all the time. Okay, second component is number sense routine, and I do 11 or 12 different number sense routines, and I thought I would show you one that's really applicable to multiplicative thinking. And I'm going to have a video on multiplicative thinking and what it is and is not, because a lot of times when we're doing multiplication, we think we're getting our kids to think multiplicatively, and really they're just still thinking additively. So what we want in a gist for multiplicative thinking is for kids to be thinking and holding within their head groups of things, which is really difficult because not only are they having to think groups, but they're having to think how many groups. So they're having to think groups of groups. So it's actually a really hard skill. And so I use quick dots as a really great routine for this. If you do things with subitizing with young children, which you should, which is understanding and recognizing quantity instead of just numbers, this is just like that. And I do it with dots, and I also do it with images. So for this one, as you can see, there's cupcakes or muffins. And what I would do is show this to my students just for 3 seconds. And their goal is to be able to figure out how many are there. And as you can see, it's kind of strategically placed to be 3 groups of 5, or sometimes kids will see it other ways, but it's strategically placed to be groups of muffins or cupcakes, because I want my kids to start seeing that, start grouping things when we're getting into our multiplicative units. So I would show this for 3 seconds. They would give me some kind of silent signal. A lot of people do thumbs. You can put the hand up, whatever you want to use as your silent signal. I give them a 2nd look if they need it, a 3rd look if they need it, and then we share out. And if my kids say they saw 15, they have to tell me how, that they saw 5s, and where are the 5s, and we circle the 5s, and how many 5s did you see? That's the ticket. They saw 3 5s, or they could have seen 3s, 5 3s, or they could have seen them in 2s with 1 extra. I just really want them to start seeing groups. And a lot of kids at the beginning will see 2s. That's where they are. They'll see 2s because they'll see pairs. They'll know they count by 2s, and there'll be extras. And then you start to encourage them when they start to realize that that's not the most effective, efficient way, because when it gets to larger and larger numbers, they're trying to count all these 2s, and other kids are counting bigger numbers, and they're getting to that answer faster. So they start to realize, oh, I can see groups bigger than 2s. I can start to see 4s. I can see 6s. I can see 7s. Really getting them to think in those groupings, which is very important for multiplication. Okay, so then I go into my high cognitive demand problem, and I picked 2 that I might pull out to show you because they're 2 kind of different forms of multiplication. So there's one that has to do with grouping, and it's really like division, but the multiplicative thinking includes division. And then there's one that is like more an array and has to do with that. So I wanted to show you both so you could get some information for both. I would probably start with the top one on my first day and maybe do the next one a little bit later when we're really honing in on arrays. But either one, they're really good. So there are 42 wheels in a bicycle shop. They sell bikes and trikes. How many of each might they have? So they're having to think of groupings of 2 or 3, or 2s and 3s. And this is when I would send my kids out in their math groupings, either in partnerships or groups of 3 or 4, with manipulatives and whiteboards and pencil and paper, and give them time to grapple with this, to represent it, to model with mathematics, to reason with mathematics, all of these things that are the mathematical process standards, really getting down doing math. And they are excited with this kind of real life problem. It's really interesting to them. It's one problem, it's up on the board, and they're doing so much math in it because they're trying to think, okay, if it's bikes, all these 2s, trikes, all these 3s. And then when they come up with a way, they can come up with another way. I asked them, is that the only amount the shop could have? Is there another amount they could have? So they're really grappling with a lot of math. And the second one is arranging chairs. You have 24 chairs. What are the ways you can arrange them in equal groups? You want to have between 3 and 13 chairs in each group. So that can be put in an array. Like a lot of the kids will put that into an array because they're chairs. Or they can be put in groupings for a party. So it's still groups and multiplicative thinking. And I encourage my kids to draw out their thinking, talk to their partners, reason, problem solve, really all of those good things. So that's 2 problems I maybe would pick out one, and that would be my high cognitive demand problem. Okay, and then I go into concept. And with concept, I like to start with some questions, kind of like the high cognitive demand. And then I always use some kind of organizers and then visuals. So I'm going to talk a little bit about visuals in just a minute. So this is maybe how I would introduce the concept for this particular idea of multiplication. So I might show the kids a picture of these children. You see a group of children there. How many arms are represented in this picture? So we can't necessarily see all their arms, but the kids can figure out, knowing with their knowledge of human beings mostly having 2 arms, that there's most likely how many kids times 2 amount of arms. And then looking at the next one that's just the arms, how many kids could there be? And this one is a little bit more creative because some of the kids might have 2 arms raised and some may only have 1. But they have to mathematically reason and mathematically prove to me why they have the solution they have. Then we go down into kind of a graphic organizer with my things that come in groups of. Again, I'm spending a lot of time getting my kids to think in groups, get their head to be able to think about and grapple with this idea of groups. So I want them to think in life things that come in groups of 2, shoes, socks, gloves, things like that. In 5s, like fingers on a hand, toes on a foot. In 6s, like Coca-Cola, like packages of soda. And in 12s, like eggs or donuts. Most of my kids always say donuts. So that's like a little bit. I would usually give this to the kids and lead discussion. They might fill out that graphic organizer with me. We would do it on our iPads. Just some conceptual kind of understanding of the topic. And then I want to talk about visuals. So visuals for multiplicative thinking are very, very important. And I say that, but it's really just important for anything. So whatever. Here's 3 visuals that I would use that are not necessarily like physical manipulatives. I just wanted to show you like visuals you can put on your screen, visuals you can put on your kid's screen, visuals you can draw on the table or print out and laminate. And I'm going to start with this red one because a lot of us know this one. It's a 10 frame. And we use 10 frames with young kids when they're working on early numeracy and making 10, the idea of 10 and the concept of 10, which is very important. 10 frames are a really good tool. You can continue utilizing 10 frames in multiplication, but instead of putting 1 dot in each box, you can put groups of dots in each box. So now instead of each dot having 1, each dot might have 3. How many 3s are there? Again, the kids are thinking of groups. So a 10 frame is a great way. You can print and laminate those. You can get those magnetic ones. You can write them on the table, all sorts of things. Over in that blue one, I put a little, normally this would be a 10 by 10. A lot of people use this, is my dots I use to help my kids build and make and arrange arrays. And if you are helping your kids build arrays and helping them see how they can use arrays to discover other arrays, which we'll talk about in a minute, you really need this kind of good visual to show them. So for example, when we start talking about our multiplication strategies and how when we get to times 6 problems, we can just think times 5 and then add one more group. I really use this visual a lot to show my kids 5 rows. Now we're adding another row and we have 6 rows, because they really need to see that visual of the strategy happening. When we do times 7, we can do 5 and 2 more, things like that. Down at the bottom, I just use circles. So this is for multiplication strategies as well. So these are groups. My kids use circles to represent groups. If you haven't done any research or reading Marilyn Burns, she does circle and stars. A really great activity that you should look into if you teach multiplication. And we do a similar thing. I don't make my kids draw stars because they can't and they get frustrated and hung up on that. So we just do dots or whatever. If we're using iPads, I let them use a school appropriate emoji and they put them in there. It doesn't matter. They're just making groups. But what I like about this visual is, so if you can see there's 2 on top, that might be 2 groups of 6. And we've been working on times 2 and how times 2 is just doubling, and the kids know their doubles facts, so we've been working on that and working on that. Now I want them to connect that to times 3 so that they have a strategy for times 3. And I will show them, if you can do times 2, 2 times 6, then you can do 3 times 6 by just adding in another 6. There's another group of 6 down there. And doing that for any number of things. So it's just kind of like the array one, but with just groups, kind of like the circle and stars idea. So those are kind of what I mean by visuals, not super over the top, things that are literally just showing kids the concept of the numbers that we're talking about, instead of just showing them numbers, and they aren't maybe necessarily getting it. I also use these with manipulatives, so I use the 10 frames out on the table and we fill them with real things. Target erasers are great for this. We all love target erasers. I also draw big circles on the table and we do that. When I'm introducing times 4, I show my kids how it can be double it and double it again, because it's a group of 2 and another group of 2. So if it's 4 times 7, you can do 2 7s and 2 7s, 14 and 14. And we really put those things into the circles and combine those circles. A lot of visuals like that, so it's really conceptual. And that would be it. From that lesson, that was really pretty quick, we would go into math stations where I would continue that concept with my students. And if my students are understanding that concept, we would go a step further with the concept and really hone in on what they need at math stations. So there's a quick example of a 3rd grade multiplication lesson that follows the 4 components, that helps kids think deeper and provides them with a lot of concept. Thanks for watching. Remember, math is natural, and happy teaching.